In my last video, we saw that my biological age using Levine's test was 17 years younger than my chronological, and similarly using aging.ai, 21 years younger. So what's contributing to these data? So first, let's start with supplements. So I was diagnosed with hypothyroidism in my mid-20s, so I've been taking levothyroxine for about 25 years, 137.5 micrograms per day. Now, for about 9 months out of the year, I supplement with vitamin D, 1,000 IUs per day, but note that in the summer I don't, especially on days that I get sun exposure. So for the 63-day period that corresponded to this blood test, I did include vitamin D, but it wasn't every day. And then occasional melatonin. So this is a very small amount. This is about 39 micrograms per day. So not milligrams, micrograms. So melatonin either before bed or in the middle of the night to help with sleep, but rarely. As you can see, 39 micrograms per day isn't much. And that's it for supplements. Nothing else, including geroprotectors or senolytics. So that brings us to diet. How is diet, or is diet, contributing to these data? So first, how am I tracking diet? Well, note that the blood test is on July 11th of 2022. So how does diet correspond to that? So my average daily dietary intake from the last blood test, which was on May 9th, through the day before, to the day before this blood test on July 10th, corresponds to blood test number 4 in 2022. So let's explain that approach a little bit more. So here we're looking at May, June, and July. So blood test number 3 was on May 9th, and blood test number 4 was on July 11th, and then in between, 63 days. So for each of those 63 days, I weigh my food. And I've done that every day since April of 2015. I've weighed my food every day using a food scale. And then I enter those food amounts into Chronometer. And that's the diet tracking app that I've used. I'm not here to say that they're the best, but that's what I've used. And along those lines, if you're interested in using a discount link for Chronometer, that will be in the video's description. All right, so then that daily data for Chronometer, I enter it into a spreadsheet. And then the average intake for those 63 days in between blood tests corresponds to blood test number 4. And because I have up to 38 blood tests since 2015, I can then correlate diet with the blood biomarkers. So so let's get into that approach a little bit further, including looking at individual food amounts. So that's what we can see here. Again, this is the average daily dietary intake from test number 3 to test number 4. It's a 63-day period, average intake. And starting at the top with the amounts in grams, we can see that strawberries were the food that I consumed the most, 622 grams per day. So why are these foods at the top? Not just strawberries, but the others on the list. So by tracking diet in conjunction with blood biomarkers, I can focus on eating foods that have positive correlative scores with the biomarkers while minimizing intake for foods that have negative scores. So what does that mean? So first, to illustrate, let's take a look at correlations for strawberry intake with big picture biomarkers. And then as a side note, although I've tracked macros and micros since 2015, I only started tracking individual food amounts since 2018. So what that means is I have 23 to up to 23 tests that correlate individual food amounts with the blood biomarkers, whereas I have up to 38 tests for macros and micros with the blood biomarkers since I started tracking that in the beginning. And it wasn't until later that I decided to start tracking the individual food amounts too. So if anyone is interested in this approach, I'd recommend tracking both macros, micros, and the individual food amounts, because the macros and micros may not fully explain food. You know, you're reducing food down to 40 or so nutrients. It may be too reductionist. All right, so correlations for strawberry intake with the big picture biomarkers. And the big picture biomarkers are listed here, and I've covered this in other videos, but let's just go through it real quick. So they include glucose, but also homocysteine, 3 markers of kidney function, 3 markers of liver function, all the major lipoproteins, immune-related cells and proteins, for example, globulin, red blood cells and their related measures, a marker of inflammation, high-sensitivity C-reactive protein, and then overall biological age score is indicated by Levine's PhenoAge and aging.ai. So as another note, the little n next to each blood biomarker is the number of blood tests that I have. So for example, for glucose, I have n equals 23. That's 23 blood tests that correspond to diet data or food intake. R at the top on the left is the little r, is the correlation coefficient. And then to the right is the p-value, the measure of statistical significance, with a value less than 0.05 being indicative of statistically significant. All right, so what's significantly associated with strawberry intake? So first, a relatively higher strawberry intake is significantly correlated with lower levels of the liver enzyme AST, lower LDL, lower platelets, and also lower high sensitivity C-reactive protein. So then the next question that I would ask is, are the significant correlations going in the right or wrong direction in terms of aging and or all-cause mortality, ACM risk? Now, I've covered how each of these biomarkers changes with aging and or all-cause mortality risk in other videos, so I won't go through that in this video. But we can see that I've put green arrows there, so these are correlations that are going in the right direction in terms of aging. For example, AST higher than around 29 or around 29 is associated with an increased all-cause mortality risk when compared with somewhere in the 18 to 22 range. So I've had AST data even higher than 40. So for me, having strawberry intake being negatively correlated with AST suggests a higher strawberry intake is significantly correlated with lower AST. So that will be going in the right direction in terms of all-cause mortality risk. So using a similar analysis for each of these 4 biomarkers, they're going in the right direction in terms of aging and or all-cause mortality risk. So that leads us to a net correlative score of +4. So what does that mean? Well, if the net score for diet with blood biomarkers was negative, I would eat below my average intake since 2015, since I started tracking diet. And if the net score was 0, I would eat close to or at my average intake for that food or macro and micronutrient. But in this case, if the net score is positive, I should eat above my average intake to follow the correlations. So with that in mind, my average strawberry intake since 2018 is 350 grams per day. And as I mentioned, my strawberry intake for the 63-day period that corresponded to this blood test was 622 grams per day. So I'm following that correlation, which suggests that I should eat above my average intake. So that gets a green check. All right, so let's illustrate another example by looking at red bell pepper. So here we're looking at correlations for red bell pepper intake with the big picture biomarker. So what's statistically significant? So we can see that a relatively higher red bell pepper intake is significantly correlated with higher creatinine, with higher levels of neutrophils, and also a lower level of lymphocyte percentage, So these are going in the wrong direction in terms of aging and or all-cause mortality risk. For example, creatinine increases during aging, so we don't want to have relatively higher levels. So that red bell pepper is positively correlated with higher levels of creatinine, that's going in the wrong direction. So all of the red arrows are going in the wrong direction. So that yields a net correlative score of -3. Now, if you remember, when the net score is negative, that suggests I should eat below my average intake. My average daily red bell pepper intake since 2018 is 298 grams per day. So for the 63-day period that corresponded to this blood test, I purposefully averaged about 248 grams per day. So I'm following the correlations because it's a net negative correlation, and I'm below my average intake purposefully. And I should say that none of these values, the diet intake values, are by accident. I carefully examine my diet every day to make sure that I'm following as many of these correlations as possible in order to get the best biomarker profile that I possibly can. All right, so how well am I following the correlations for the other high intake foods, which can help address the question, why are these foods at the top in terms of intake? So I've already shown strawberry and red bell pepper. So for carrots have a net score of +1, and they are significantly correlated with lower homocysteine. Homocysteine increases during aging, and relatively higher levels are associated with an increased all-cause mortality risk. So that would suggest that carrots, if correlation equals causation, and that's a big if, that carrots may reduce homocysteine in my case. I don't know if that's causation, but that's what the data suggests. So my average intake since 2018, since I started tracking food intake, is 372 grams per day. And because the correlation is positive, that suggests I should eat above 372 grams per day. But note that I was at less than that for this test, so we give it a red X. Now, the carrot story is a little bit complicated because carrots are a rich source of beta-carotene, which as we'll see in a bit, beta-carotene has a net negative correlative score, so I have to be careful with my total amount of beta-carotene containing foods, including carrots and then green leafy vegetables, broccoli, even things like red bell pepper, etc. All right, so for some of the other foods on the list, mushrooms have a net score of +4, and you can see with the significant biomarker correlations, the foods that are going in the right direction are listed in green, and going in the wrong direction are listed in red. So actually for mushrooms, it's 5 biomarkers going in the right direction, 1 in the wrong direction to get that net score. So average intake is 42 grams per day. I used to eat a lot more mushrooms prior to 2018 before I started tracking individual food amounts. And it wasn't only until about somewhere around this year that I added them back into the diet. And we can see that they've got that net positive score. So that looks like it was a good idea. So 231 is above 42 because the net score is positive. It suggests I should eat above my average intake. So I'm following that correlation. All right, next up, beets. And we can see that beets have a net score of +8. And I'm not a fan of the term superfoods, but with a net score of +8, that would suggest that beets may be a superfood for me. We can see that they're significantly positively correlated with all eight biomarkers going in the right direction and none going in the wrong direction. So my average beet intake since I started tracking food intake in 2018 is 115 grams per day. And we can see that for the 63-day period that corresponded to this test, I'm above that, so we give it a green arrow. All right, collard greens, net score of +1. This is one that I just recently added into my diet, switching it out for spinach, which are high in oxalates, and I was eating a lot of spinach. And oxalates actually have a net negative score with my blood biomarkers. I won't show that data here, but if anyone's interested, I can indicate which biomarkers are going in the right and wrong direction with oxalate intake. So nonetheless, my average intake for collard greens, 14 grams per day. Since I'm above that, I'm following the correlations. We give it a green arrow. All right, so then last but not least, watermelon intake. Watermelon has a net score of +5, 5 biomarkers going in the right direction, none in the wrong. My average intake since 2018, 152 grams per day, and 200 is above 152, so I'm also following that correlation. So as I mentioned, by following the correlations for as many foods and macros and micros as possible, I expect that my best biomarker profile will result. Now, whether that's the case, I don't know, but the biomarkers are looking pretty good for now, so I'd argue that diet may be contributing. All right, so what about the rest of the diet? Here are the first 23 foods, but where's the rest of it? So we can see that here, same approach, amount in grams at the top, and then 40. So I ate 46 different foods for this 63-day period that corresponds to test number 4. Now note that it isn't always clean. I do include junk, and when I do, it's immediately after the blood test on blood test day, and then on the day after, and then I shut it down until the next test, or I try my best to shut it down. So in this case, it was 61 days with no junk food. So the quote-unquote junk food for this test was a small bag of M&Ms, as you can see by the red arrow, but then also store-bought peanut butter, which is roasted and has salt added to it. And although that may not qualify as junk, I usually eat all my nuts and seeds raw to limit age products. So I put that in the junk category for now, even though there's far worse things to eat, including M&Ms. And then also I chew gum during my standard 75 to 80 minute workout that I do once every 3 days. So that's a couple pieces of gum every 3 days. So that's also in the junk list. All right, so what about the macronutrient and micronutrient profile? How does that correspond to test number 4? So let's start off by taking a look at calorie, protein, and fat intake that corresponds to this blood test. So as I mentioned, I have up to 23 blood tests that correspond to food intake since 2018, but up to 38 tests that correspond to macros and micros since 2015. So let's start it off by looking at calorie intake. So my calorie intake for the 63-day period that corresponded to this test was about 2302. And then is that too high? Is that just right? Is that too low? To address that, we can do a correlation analysis for calorie intake versus the big picture biomarkers. And when I do that, calorie intake has a net score of -5, including higher levels of these 5 biomarkers: alkaline phosphatase, ALP, the liver enzyme AST, LDL, platelets, PLT, and the red blood cell distribution with RDW. So in other words, a higher calorie intake is significantly correlated with higher levels of each of these biomarkers, which is going in the wrong direction in terms of aging and/or all-cause mortality risk. So with the net negative score, that suggests I should eat below my average intake in order to minimize any potential detrimental effects of calorie intake on the blood biomarkers. So my average intake since 2015 is about 2550. So we can see that for this test, I follow the correlations by eating less than my average intake, so it gets a green check. All right, so next up, protein intake, about 96 grams per day. So why 96 grams per day? Again, we'll go to the correlation analysis and see why that amount. And just as a quick note, that's 16.6% of my total diet composition is from protein. So correlation analysis, protein intake has a net correlative score of -8. And you can see that 9 biomarkers are going in the wrong direction in red and only 1 homocysteine going in the right direction. So that suggests I should eat below my average intake, which is about 113 grams per day. And again, this isn't by accident. I know these correlations because I reevaluate for every test. And knowing that protein has a net negative correlative score, I aimed for 96 grams of protein for this test so that I'd be under my average intake since 2015 of 113 grams. All right, so we give it a green check because I'm following the correlations for protein. All right, so what about fat intake? So for this test, I averaged 80.5 grams per day of total fat, and that's 31.5% of my total diet composition. All right, so why 80.5 grams for fat? So again, we go to the correlation analysis, and we can see that total fat intake in my data, it may be different for other people, has a net correlative score of -7. And it's significantly correlated actually with 9 biomarkers going the wrong direction and only 2 in green going in the right direction. So that suggests that I should eat below my average intake, which as we can see is 86 grams per day. And because 80.5 is less than 86, I'm following that correlation by eating under my average intake when the net correlation score is negative. All right, so total fat can be further subdivided into mono and polyunsaturated fats. So first, starting with the monounsaturated fats, we can see that even though they're purported to have health benefits and eat more olive oil and all that, even though my diet doesn't contain oils, it's from whole foods, we can see that monounsaturated fats have a net negative correlative score in my data, including being significantly correlated with higher levels of glucose and red blood cells. All right, so that suggests I should eat less than my average intake, which is 16.9 grams since 2015. And because 16.4 is less than 16.9, I'm following that correlation too. So polyunsaturated fatty acids can be then further subdivided into omega-3 and omega-6. And as I mentioned, Chronometer may not be perfect, but that's what I've used since 2015. You can see that omega-3 and omega-6 at 8 and 16 grams per day should add up to the polyunsaturated amount of 23.5. But individually, 24 is higher than 23.5. So Chronometer is not perfect, but this is what I've used since 2015. So going to the correlations, omega-3 has a net positive correlative score of +2, and it's significantly correlated with 5 biomarkers going the right direction, as shown in green, and only 2 in the wrong direction. So that suggests I should eat above my average intake, which is 7 grams per day. And because 8 is higher than 7, I'm following the correlations there. Similarly, omega-6 has a net positive correlative score of +3, including those biomarkers there. So that suggests I should eat above my average intake, which is 15.5 grams. And we can see green check because I'm also following that correlation. Now, saturated fat has a net correlative score of -7, so I should eat below my average intake in order to minimize any potential detrimental effects if correlation equals causation for saturated fat on the blood biomarkers. So my average intake for saturated fat is 27 grams per day, so I was at 21 grams per day for this test, so again, I'm following that correlation too. And then cholesterol, very strong negative correlative score of -9, including those biomarkers there, 9 going in the wrong direction, none in the right. So that suggests I should eat below my average intake, which is 129 milligrams per day. So we can see 22 is less than 129. So I'm following the correlation. So to sum, I'm 6 for 6 in following the correlations for fat intake with the big picture biomarkers. And again, this isn't by accident. I purposefully aim for either above my average intake, below my average intake, or right at my average intake based on what these correlations show. All right, so what about carbohydrate intake? So first, my net carb intake was about 250 grams per day, which translates into 52% of my total calories. So is that amount too much? What is the correlation? What do the correlations show? So net carbs have a correlative score of +1, which suggests that I should eat above my average intake, which is about 235 grams per day. And we can see 249.5 is higher than my average intake, so it gets a green check. All right, so fiber has a net correlative score of +1, so I should eat above my average intake, which is 97 grams per day. So 90.5 is less than 97, so we give that an X. But for those who are familiar with my channel and who have seen previous videos on my diet breakdowns for other biological age tests, including test number 3 in 2022, my fiber intake for test number 3 was 86.5. So I increased it by a little bit, just obviously not enough to get above 97.1. So there are more details in terms of why I didn't just add a whole bunch more broccoli or other high fiber containing foods to get higher than 97.1 grams of fiber per day. So if anyone's interested in that story, just leave a comment and I'll be happy to explain the why. All right, so then in terms of sugars, I track total fructose, which is defined as fructose plus sucrose divided by 2. So 62.4 grams of total fructose per day for the 63-day period that corresponded to this blood test. All right, so net correlative score, total fructose has a net score of -2, which suggests that I should eat below my average intake, which is about 86 grams per day. So because 62 is less than about 86, I followed that correlation too. All right, so what about micronutrients? And I won't go through all of these. I'm just going to highlight some key points in the vitamins and minerals. So first, starting with the first half of vitamins. So we'll take a look at the net correlative score and then my average since 2015 and whether or not I'm following the correlation or not. And again, here, if anyone's interested in which biomarkers are going in the right or wrong direction, just leave a comment for each of the vitamins and minerals and I'll be happy to share that information. So first up, niacin. Note that it has a very positive score of +6. My average intake since 2015 is about 36 milligrams per day. For this test, I averaged about 41 milligrams per day. And because the score is positive, I should eat above my average intake. 41 is greater than 36, so I followed that correlation. Now, note that the RDA for niacin is 16 milligrams per day. So if I only ate at 16 milligrams per day, because of the net correlative score being so highly positive, that would suggest I would limit myself on any potential causative effects of niacin intake on the blood biomarkers. So this approach can help get closer to what is optimal at the individual level, not just for individual foods, but also macros and micronutrients, including vitamins and minerals. So that addresses the question, beyond the RDA, what's optimal? Should we just aim for the RDA, or what's optimal beyond that? And the niacin story, with 2.5 times higher than the RDA, would support this approach in trying to figure out what's optimal at the individual level. All right, in contrast, B12 has a very strong negative correlative score of -7. And my average since 2015 is 556 micrograms per day. Obviously, that's with supplementation of about 1,000 micrograms per day for a lot of the past 7 years. Now, for this test, I only averaged on purpose a 10.6 micrograms per day, knowing that B12 has a strong negative correlative score in my data. So we give that a green check because I'm following the correlations, eating below my average intake. But that's another example too. The RDA is 2.4 micrograms, so I'm already 4.5 times higher than the RDA. So again, it goes to that question of how much above the RDA is optimal. Is it 1x, 8x? Clearly not, 25x, because my average intake would be too high based on that net correlative score of -7. And then also beta carotene, as I mentioned back with the carrot story, beta carotene has a very strong negative correlative score in my data of -6. So my average intake since 2015 is about 54,000 micrograms of beta carotene per day. For this test, I purposely averaged about 50,000 micrograms, or it's actually equivalent to about 50 milligrams. So I'm following the correlations. Now, beta carotene, one of the biomarkers that is significantly correlated in my data, is with albumin. So I don't want to cut it too low because I may limit any potential effects of beta carotene on albumin. But if I go too high based on the net correlative score, it may negatively impact many biomarkers. So I'm aiming for just a bit below my average. And note that there's no RDA defined for beta carotene. So this approach can help one get towards what's optimal for each individual micronutrient, even without an RDA. All right, so finishing up the other half of the vitamins, some key points. Vitamin E with a net score of -6. Now my average intake since 2015 is about 25 milligrams per day. So for this test, I aim for 20 milligrams per day, falling on 19.8. So because the net score is negative, I should eat below my average intake, and I did that, so green check. So the RDA for vitamin E is 15 milligrams per day. So if one just went with a general rule of I'm going to eat X amount above the RDA for all vitamins and minerals, as you can see by my data, things like niacin, 2.5-fold higher than the RDA. B12, I'm right now about 4.5 times higher than the RDA. So there's no general rule for all micronutrients. As you can see by vitamin E, somewhere around 20 may be optimal for me, but if I go higher, that's associated with more biomarkers going in the wrong direction than right. So in other words, I wouldn't say that there's a general magnitude that each micronutrient should be higher than the RDA. It's individual, and each should be assessed individually to figure out what's optimal for each, again, individual micro or even macronutrient. All right, so then also looking at vitamin K. Vitamin K has a net correlative score of +3, so I should eat above my average intake, which is about 1550 micrograms per day. And we can see that I was about 1880 micrograms per day. And again, I do that on purpose. It's not by accident. And so we give that a green arrow. Now, note that what's defined as the RDA or AI, adequate intake, for vitamin K is only 120 micrograms per day. So in this case, I'm more than 15 times higher than the RDA. Now, if 15 times higher was too much, I'd expect to see more biomarkers going in the wrong direction than right. And as a perfect example of that, B12. Clearly, B12, which has a very negative correlative score, going too high may be bad for all of my many of my biomarkers. All right, so last up are the minerals. So some key points. Calcium has a score of -7. So that suggests I should eat below my average intake. So we can see I did that there. Iron, net score of +5. That suggests I should eat above my average intake of 28 milligrams per day. So I did that there, about 31 milligrams per day. And that's another interesting one in terms of the RDA. So the RDA for iron is only 8 milligrams per day. So there I'm 4x higher with a net score of +5. And again, I'm 4x higher because after seeing that it's a net positive score, I purposely go higher to see how high, how high can it go? How high should I go in order to define what's optimal for me at the individual level? And then last on this list is sodium with a net score of -4. So that suggests I should eat below my average intake there, which we can see that I did. 1732 is less than 1889. Now, the RDA for sodium is less than 2300. But with this this approach of looking at the correlations and then basing the diet based on that, we can see that maybe even 1900 milligrams of sodium may be too much for me, and going a little bit lower may be optimal. So, all right. So just as a last note, by using this approach, I can get closer to what's optimal at the individual level for n equals 1, which goes beyond the RDA or inadequate intake, AI, for many nutrients. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon. And then discount links, which will be in the video's description. If you're interested in using diet tracking with Chronometer, there's a 10% discount link there. If you're interested in quantifying your oral microbiome composition, there'll be a discount link there, and you can use my code ConquerAging15. Or if you're interested in supporting the channel, you can use Buy Me a Coffee, and again, that link will be in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.